Moving averages convergence divergence, or MACD, is a centered oscillator that measures a stock's price momentum and identifies trends. 12 days are commonly used for short-term smoothing, 26 days for long-term smoothing, and 9 days for signal. For full reference, I recommend that you read Gerald Appel, Technical Analysis, Powerful Tools for Active Investors, published by Financial Times Press in 2005. Its calculation has the following steps. A. Short-term, 12 days, and long-term, 26 days smoothing calculation. Therefore, we have the short-term, or 12-day smoothing, which is our current EMA of 12 days, which is equal to 2 divided by 12 plus 1, multiplied by the current close minus the previous EMA of 12 days, plus the previous EMA of 12 days. For our initial EMA of 12 days, it is equal to 12-day simple moving average of those 12 periods of close prices. For our long-term smoothing, we have our current EMA of 26 days, which is equal to 2 divided by 26 plus 1, multiplied by the current close price minus the previous EMA of 26 days, and this result plus the previous EMA of 26 days. For our initial EMA of 26 days, it is equal to a 26-day simple moving average of those 26 periods of close prices. B. Moving averages convergence divergence indicator calculation. Our moving averages convergence divergence of 12 and 26 days in their corresponding short-term and long-term smoothing, it is equal to the EMA of 12 days of close prices minus the EMA of 26 days of close prices. C. 9 days moving averages convergence divergence indicator smoothing calculation. This corresponds to the signal of those 9 days, which is equal to a 9-day exponential moving average of the MACD for 12 and 26 days. D. Moving averages convergence divergence indicator histogram calculation. The MACD histogram of 12 days, 26 for shorter and longer term smoothing, and 9 days for the signal is equal to the MACD of 12 and 26 days minus its corresponding signal of 9 days. Great, so let's go back into our Python PyCharm IDE so that we can study moving averages convergence divergence, or MACD, with greater detail. Excellent, so here we are back within our Python PyCharm IDE. In this lecture, we'll be working within moving averages convergence divergence code file. If you have any questions about its setup, please go back to section 1, Stock Technical Analysis Data Lecture, where all of that explained with greater detail. So as all of these are meant to be standalone type of files, the first step is we do our packages importing NumPy as MP, Pandas as PD, Matplotlib as PLT, and Talib as TA. Then as default, we do the corresponding data reading, which is SPY data frame of our corresponding Standard & Poor's 500 ETF equals to pandas or PD dot read underscore CSV, the path to our corresponding data file, which is right over here within our data directory, and the text file, which includes CSV or comma separated values, index column as date, and we parse those dates as true. Then we proceed with our moving averages convergence divergence indicator calculation and chart. So we have the corresponding columns for our MACD, its signal or MACD EMA, and its corresponding histogram. For this, we do the calculation through Talib's or TA MACD with capitals, and we're going to supply np or numpy.asArray close prices. Then the parameters for the indicator are the fast period 12 days, the slow period 26, and the signal of 9. Again, these are the parameters commonly used for this indicator, but you can modify them according to your needs. Then we do the corresponding chart, which is fig1, AX or axis equals PLT.subplots, two of them which share X equals true. On the first of the subplots, located at position 0, we plot close prices and the legend at the upper left. Then, on the first of our corresponding subplots, the one that goes below, which is our oscillator at position 1, we plot MACD, its signal, and then the histogram. And just to identify from the other two lines, we have a line style with two dashes, which is a dash type of line style. Then we add the legend at the upper left, and we give a superior title to this subplots, which is SPY close prices and moving averages convergence divergence MACD of 12 days 26 for shorter and longer term smoothing on 9 for the signal. Then we show the chart. So let's run the code by clicking the right button on the mouse and scrolling down into run moving averages convergence divergence or MACD. So let's make this chart manually as a full screen because of the screencast right here. So let's right over here and then just to the bottom. Perfect. There we are. So we have SPY close prices and moving averages convergence divergence MACD, again 12, 26 and 9 days for its calculation. On the top subplot we have our close prices, and the one on the bottom is our technical indicator as an oscillator. Notice that those share the corresponding horizontal axis or dates, which begin in 2016 and end at the beginning of 2017. So we have close prices as solid blue line, and below we have the technical indicator with that blue line, that's the MACD. Then we have in orange its EMA or signal, which is the 9-day smoothing of the MACD for 12 and 26 days. And finally we have their difference, which corresponds to the MACD histogram, which is the dotted green line on the back. Excellent. So let's close this chart here. We're also going to close this other charts because we'll study in our following sections. Excellent. So now that we've finished studying our moving averages convergence divergence indicator, it's time to continue with the next of our leading type of indicators, and now it's time to study our rate of change, which is our following objective.